Hi, welcome to our pre-calculus. Topic today is proving an identity using fundamental trigonometric identities, problem type 1. So in these set of problems that we are going to see from now on, we are going to supply the steps, unlike the previous ones where the steps were supplied and we were just naming them. So those problems were called verifying an identity. So step by step we just checked that it was actually correct. Here we have to provide the steps ourselves. So like what would we do to show that the left hand side is always equal to the right hand side? So in this case 1 minus sine of x times 1 plus sine of x, then it's an example of algebraic identity. Let me just remind you that in algebra, if you have a minus b times a plus b, you get a squared minus b squared. So that is what we are doing here to supply our so let's go back to the original page. So 1 minus sine times 1 plus sine is going to be 1 minus sine to power of 2 step forward x. What rule did we apply? We just did algebra. Okay, is that correct so far? Well, let's check. So it looks like it was okay. Then from 1 minus sine squared to cosine squared, we are applying the Pythagorean identity. So here we write first of all cosine power 2 step forward x. How did we come to that? Well, we applied the Pythagorean identity for that. Let's validate our step. So it says you're complete. Now let's go to another one. Secant plus 1 times secant minus 1, that's equal to tan squared. So first of all, the product of these two will be secant to power of 2 of x, then minus 1. What did we do here? It's just algebra, so we did algebra. Then validate secant squared minus 1, that was one of the Pythagorean identities. Let's see, it shows it to us. Oh, sorry. Let's again, Pythagorean identity. What were the list? So secant 1 plus tan squared is secant squared. You can rearrange this in multiple ways. For example, if you take the 1 to the right hand side, secant squared minus 1 will be equal to tan squared, and that is what we have here, secant squared minus 1. So we write here tan square of x. You can just type, or you can use the keys here. Typing will be faster. So validate. Try another one. Secant to power 4 minus secant to power of 2 is tangent to power of 2 plus tangent to power of 4. So the problem becomes gradually more interesting because the number of steps is going to increase. You might have seen this problem before. Let's see. So here what can we do on the left hand side so that it looks like right hand side? One of the things we can do is by factorization. Plenty of things that are available to us at the first round. What works, we have to see step by step what actually works. So let's just plow through, see what happens. So I can factor, so I say secant to power 2 of x times 1, we have secant to power of 2 of x again, times secant to the power of 2 of x, and then minus 1. So what did we do here? We just factored. What is factorization? It's just an algebra activity. Am I correct? Well, it looks like I'm correct. Now, secant square can be written as 1 plus tangent square. You remember the trig identity 1 plus tan square of x. That is the secant square. The other secant squared minus 1 can be written as the, well, let's do step by step so that the software doesn't complain to us we're doing too many things at the same time. So do one step at a time, so that one rule at a time. Sometimes you might apply multiple rules. So this one I keep, and that one is the only one I change. And what is the rule there? That's of course a Pythagorean. Am I correct? It looks like I am. Now 1 plus tangent square, no, 1, I forgot the plus, tan square, I keep it as it is. Secant squared minus 1, that's a trig identity, that's just tangent square of x. So we applied Pythagorean again. So here's another Pythagorean. Now I, well, verify. And then now I multiply through. Why do I do this? Because that's what I want to create on the right hand side. I have tan squared plus tan to the 4. So when I multiply them, my identity is going to look like plus tan to the power of 4 of x. So to enter x, you step forward with the right arrow and then select the rule. All we did was to apply algebra, validate, and your proof is complete. Let's do maybe one more. 1 plus tan squared is secant squared plus 2 tan x. Well, 1 plus tan squared. Let's remember that if you want to square some of two items, square of first item, square root of second item, and twice the product of the two. So those are things to have here. So 1 plus tan squared, square of 1 is just 1. Square of tan squared, well, that is tan to power of 2 of x, and then plus 2 tan x. What did we do so far? We just applied squaring identity. It didn't do anything trigonometric. Now 1 plus tan squared is same as secant squared. So secant to power of 2 of x, and then plus 2 tan x. What we do, we apply the Pythagorean, because 1 plus tan squared is secant squared. Validate, and you're done. And so on you go. Try to do like 10 of these things all put together, perhaps under 5 minutes, 10 of them under 5 minutes. That's what you need to do when you get to calculus. Okay, until next time, good luck and God bless.